Okay, I have a little problem. I need to set up a double monitor system.
You mean presenter?
Yeah. Um, right now it's only, which is the same thing that was working on my other. Well, I'll start off by explaining that this presentation is strong on internet, strong on IPFS, not so strong on Filecoin. The simple title, IPFS, Filecoin, and the new internet, focusing on how the internet could be better than it is right now. Okay, during this era, everyone uses the internet in a variety of ways, from research to news to social matters and a long list of functions. But how does the internet really work? Is it really safe to use? What are the possible problems? And how can it be improved? This graphic shows how most people think the internet works. First, minus First, we type in our web address, forward, okay? Then, our computer sends a request for data from the World Wide Web, and the web responds and sends the data back. And finally, our computer can use the data. For our purposes, a more accurate description of the workings of the internet are as follows. We type in a web address, then our computer searches the local internet cache for the data, but if it doesn't find it, it then sends a request for the data to the World Wide Web. The web responds and sends the data back to the local cache. And finally, our computer can use the data. Essentially, it is the same as the previous view. But in the case of a repeat request for data, our computer searches the local internet cache for the data. It is found there, and so it immediately returns the information to your computer. No request needs to go through to the World Wide Web. Now, let's look deeper. What we need to remember is that computers on the internet are not really known by their names, but by their ID numbers, known as IP addresses. So, when you want to browse a certain website, hello? Okay. That web address needs to be converted to the correct IP address. This is done by sending the server name to the local domain name cache on your computer. Assuming this is the first time this address was browsed, the cache will be unable to convert the server name and sends the request to the global DNS. There are actually several layers and servers, but let's not get too complicated. The domain name servers convert the web address to the correct IP address and sends it back to the local cache, which stores it and sends it to the browser. The browser uses the IP address and connects to the website and requests the information and then displays it. In a case for new data from the same server, our computer searches the local internet cache. It is not found there. And the local DNS cache for the data, it is found there. The IP address is returned immediately. No request needs to go to the global DNS. The information request goes to the website using the IP address, and it is returned to the computer and used. So, what could go wrong? Well, lots of things. The server could come under attack by hackers. There are many kinds of server attacks. Those who control the server may choose to take it offline, or offline for certain people. The DNS system can be compromised. Again, there are many different ways. Even the local DNS can be maliciously affected, as can the computer itself. Some of these can be under your control, some are not. Some of these you might notice are happening, or you might not. But when any of these happen, portions of the internet, or even all of it, will be unavailable. As we have seen, the main method of address of the internet now is by location. This does have its advantages, and we saw that it has its disadvantages as well. Another issue is the current internet, with the current internet, is its centralization, making it easy to be attacked, resulting in users not having access to the data. Furthermore, because of the centralized, non-redundant location of data, a failure in the server, intentional or otherwise, will result in the information residing there becoming unavailable. Then there's the ability of corporations or governments to censor material totally or selectively. This is already being done. These can hardly be considered ideal conditions. Enter the IPFS, the Interplanetary File System. And, like the name says, this kind of internet is useful for locations where servers might be distant from users, like between planets. As an example, the time it takes for a signal to travel between cities on the Earth is typically measured in milliseconds, up to maybe a maximum of 1 second. But if we were to have internet access to our nearest neighbor, the Moon, where scientists plan to have an outpost within 10 years, that time would go up to about 10 seconds. Maybe not so long a wait. Now, let's consider our nearest interplanetary neighbor, Mars, where scientists would like to start a colony within a few decades. The signal travel time is anywhere from 8 to 28 minutes. I wouldn't want to wait for that. Obviously, the current implementation of the internet would not work in this case. Something else is needed that has non-centralization and redundancy built into it. This is exactly how the IPFS works. Now, let's take a look at the new IPFS internet. First, we type in a web address, then our browser takes the file we want, gets a fingerprint called the content ID, and asks the network who has a copy. Various computers may respond. Our computer prepares to receive the file,